All right, so for this video, what we're going to do is we're going to be able to use ratios and proportions to decide whether two polygons are similar. And then later on, we'll be able to find unknown silence of similar figures. Not in this video, that's the next video. All right. So one of the things you need to know about similar figures is it's close to what we were learning before a few chapters ago about congruent figures, except for one difference is the shapes will be different sizes. So if I have this triangle here and this triangle here, they could be similar. Now there's some things that we're going to talk about to be able to identify if they're similar or not, but what it's saying is one of the figures is either enlarged of the other or it's a shrunken version of it. But they have a lot of similar traits, and we'll get into that. But you'll see there's a few things that we must do that was very close to what we had to do with congruent figures. Congruent meant everything was exactly the same. The size, the shape, the angles, everything was exactly the same. Similar, they have close, like their traits are very similar, but one figure is an enlargement or a shrunken down version of the other one. And the symbol to say that they're similar is this tilde looking symbol here. So we would say that they are similar using that symbol. All right, so our goal or objective for this video is to be able to identify are two polygons similar, and in the next video we'll be able to solve for the missing silence. All right, so just like with the congruent figures, one of the things that we have to show is that all the corresponding angles are congruent. So nothing changes with that. So we still have to show that all the corresponding angles are congruent. So angle A and angle G correspond and they're congruent. Angle B and angle H correspond and they're congruent. Angle C and angle I correspond and they're congruent. And angle D and angle J correspond and they're congruent. So nothing changes with that. We must show that the corresponding angles are congruent. All right, so that is actually nothing different than what we've learned with congruent figures. Now, what does change is that the corresponding sides are proportional. So that means that the ratios between the corresponding sides are the same. So if you notice here, they don't say that AB is equal to GH because they would be corresponding in this case. It says the ratio of AB over GH because they are corresponding sides. So that ratio is the same ratio as BC over HI. All right, so it's the ratios between the sides now are going to be the same. So it's no longer that the sides have to be exactly the same, but they are proportional, meaning that when we create the two ratios and we set them equal to each other, that they are the exact same. All right, so it's very close to congruent figures, that all the angles have to be exactly the same. All corresponding angles need to be the same, so nothing changes with that. But now we would just look and see, are all of these sides proportional? So are all the corresponding sides that we have, can we create the same ratio between them? All right, so if we look at these two triangles here and we want to know, are they similar? So forget about the scale factor right now. We're going to go through that in a minute. But if we just looked at these triangles and said, are they similar? I know it tells us that they're similar here with that similarity statement, but if we want to know if they're similar, first we need to look and see, due to corresponding angles, are they congruent? Well, it tells us A is congruent to X, it tells us C is congruent to Z, and it tells us angle Y is congruent to angle B. So we know all the angles are congruent. Then we would have to see, do all of these sides give the same ratio? Well, AB corresponds with XY, so we can say 15 over 6. And then we would say BC corresponds with YZ, and that would then be, so we're asking, is it equal to 20 over 8? And then we have AC and XC, and we're asking again, are they equal? So AC over XC. Now, what's important that you saw that I did here is all three of these numbers I'm highlighting yellow. Let me write the numbers. AC is 25 and XC is 10. All of the numbers I just highlight in yellow are of this triangle ABC. So all of my ratios were triangle ABC to triangle XYZ. So all of my ratios were triangle ABC to triangle XYZ. So I stayed consistent in all of these. All right, then we would just reduce all of these. So 15 over 6 reduces to 5 over 2. We're still asking, are they equal? 20 over 8 reduces to 5 over 2. and 25 over 10 reduces to 5 over 2. So since all of these are the exact same ratio, that means that they're all proportional. Yes, they are similar because all the angles were congruent and they were proportional. All right, now this number that we just got here, 5 over 2, that actually represents something, and that is our scale factor. All right, that is our scale factor. And the scale factor is the ratio of corresponding linear measurements of two similar figures. Now, what is important is that you identify what our ratio is. So since this is ABC to XYZ, and that's what we did with all of these, we did our ratios as ABC over XYZ. Our ratio, or our scale factor of this, is 5 over 2. If it were to ask what is the scale factor from triangle XYZ to triangle ABC, well, then all of these would have all been reciprocals, which then means the scale factor will be 2 over 5. So it's very important that you're identifying which triangle we're starting from, or which polygon we're starting from, and which one we're going to. All right, so this one will be a scale factor of 2 over 5, while this one is 5 over 2. And it's because we changed in which one how we're creating our ratios. All right. Another thing that this might be referred to as instead of a scale factor is your similarity ratio. All right. That is another way that you might see your book refer to this. So this here, something that is very similar to what we did before, that is our similarity statement. So let me just erase this little arrow and I'll write similarity statement, which is saying that the two triangles are similar. And I went through and showed you how we would go through saying that the triangle is similar. And this is our symbol for saying that they are similar. All right, now there's this one example that we're going to go through, and then we're done with this video. All right, so this question is triangle ABC similar to triangle DEF? So we're telling us how exactly we want to go, what triangle we're starting with, and what triangle we're going to. If they are, then they want us to write a similarity statement and then find the scale factor. And we need to find our scale factor from triangle ABC to triangle DEF. So the first thing you need to do is identify, do we have three congruent angles that are corresponding? So angle C is congruent to angle F. Angle A is congruent to angle D. And angle B is congruent to angle E. So the first thing we should do is look and see, do these angles match up in the way that they're asking us to write the similarities? So is ABC similar to DEF? Well, A corresponds with D and that they're congruent, so we know that's check. B corresponds with E, and we know they're congruent, so we can check that one. C corresponds with F, and we know they're congruent. So remember, the first thing you need to do is you need to identify, are the corresponding angles congruent? All right, now we need to check all of our ratios. So they want us to go from ABC to DEF. So AC corresponds with which side? So we went from 2 arc marks to 1. So 2 arc marks to 1 is DF. And then we will ask ourselves the question, is this equal to the ratio? So AB, we have to keep AB in our numerator. One of the common mistakes is people will flip and put AB in the denominator next time. So you must stay consistent. The same triangle needs to be in your numerator and the other triangle needs to be in your denominator. And we went from 2 arc marks to 3 for AB. So 2 arc marks to 3 is DE. So is their ratio the same? And then our last one is BC and EF. So BC over EF. Now we'll substitute the numbers. So AC is equal to 8. DF is equal to 10. AB is equal to 12. DE is equal to 15. And BC is equal to 16. And EF is equal to 20. All right, now we will reduce all these fractions. 8 over 10 reduces to 4 over 5. And we're asking ourselves, is that equal to? 12 over 15 reduces to 4 over 5. And 16 over 20 reduces to 4 over 5. So since all of these are the exact same ratio, that means that they are proportional. So yes, all of the angles match up and all the sides are proportional. So yes, they are similar. So our similarity statement would be triangle ABC is similar to triangle DEF. So there's our similarity statement. And then the scale factor is whatever our proportion or ratio was. So the scale factor is 4 over 5. All All right, and remember that scale factor will change depending on which triangle we're going from and which triangle we're going to. All right, that's it for this video.